Estimating the cost of electrical finish work on a house with an older rough-in requires careful assessment. The age of the rough-in, performed between 2002 and 2004, presents challenges due to faded markings and unknown code compliance. Here's a breakdown of factors to consider for a ballpark estimate. Firstly, consider material costs. For a 1,600 square foot home with approximately 80 switches and receptacles, plus recessed lighting fixtures, phone and cable jacks, and a doorbell, the material costs can range from $1,500 to $2,500. This includes the cost of a new panel if a suitable faceplate cannot be found and a replacement is necessary. Secondly, estimate the labor costs. Assuming that trace and cables and code corrections will add approximately 50% to the overall labor, the labor costs could range from $2,500 to $4,500. This is just a rough estimate and can change. Thirdly, the total estimated costs will fall between $4,000 and $7,000, combining both material and labor expenses. Keep in mind that these numbers are for general guidance and you should adjust as needed. Now, let's consider additional factors that can impact the estimate. Tracing cables will require time and effort, dependent on the complexity of the rough-in and accessibility. Allocate an extra $500 to $1,500 for this task. Regarding the missing panel faceplate, a complete panel replacement might not always be necessary. Contact the panel manufacturer directly or an electrical supply house specializing in discontinued parts to explore alternative solutions. For code corrections, the costs are contingent on the specific issues identified during inspection. Budget an additional $200 to $500 for upgrades or modifications needed to meet current code requirements. It's also prudent to establish a contingency fund, typically 10 to 15% of the total estimate, to cover unforeseen expenses or additional work discovered during the project. I recommend conducting a comprehensive inspection of the existing rough-in work. This assessment will help you identify potential challenges such as unmarked cables, non-compliant wiring, and any other issues that may impact the project's scope and cost. Then, after the inspection, communicate the findings and potential additional costs to the general contractor clearly. Ensure that they understand the factors influencing the estimate and any potential cost overruns. Provide options. If the panel faceplate is unavailable, offer the option of a new panel versus tracing and repairing the existing one. Explain the pros and cons of each approach, including cost, time, and potential risks. Lastly, present a detailed breakdown of the estimate to justify the costs. Itemize the materials, labor, cable tracing, code corrections, and contingency fund. This transparency will help the general contractor understand the value you bring to the project. Now let's talk more about the electrical panel itself. Understanding the electrical panel is critical for any electrical work, especially when dealing with older installations. The panel, often called the load center or breaker box, serves as a central distribution point for electricity in a building. It receives power from the utility company and distributes it to various circuits throughout the structure. Inside the panel, you'll find circuit breakers. These are protective devices designed to interrupt the flow of electricity in the event of an overload or short circuit. Each breaker protects a specific circuit, preventing damage to wiring and equipment. It is designed to protect from situations such as, for example, a toaster causing a short. The panel's amperage rating indicates the maximum amount of current it can safely handle. This rating is crucial for determining the overall capacity of the electrical system. Common residential panel ratings include 100 amps, 150 amps, and 200 amps. Make sure that the panel's rating is adequate for the home's electrical demands. The electrical panel's busbars are conductive strips that distribute power from the main breaker to the individual circuit breakers. These busbars must be in good condition to ensure reliable power distribution. When inspecting the panel, check for signs of corrosion, overheating, or damage to the busbars. Also, look for proper grounding. Grounding is essential for safety, providing a path for fault current to return to the source, tripping the circuit breaker and preventing electrical shock. Verify that the panel is properly grounded to a grounding electrode, such as a ground rod or metal water pipe. Now let's discuss identifying circuits. Identifying circuits in an existing electrical system is important for safety and troubleshooting. This becomes more challenging when the original markings are faded or missing. Here are several methods to identify circuits. One method is circuit tracing. A circuit tracer, also known as a circuit identifier or breaker finder, is an electronic device that helps you locate the corresponding breaker for a specific outlet or fixture. The tracer consists of a transmitter and a receiver. The transmitter is plugged into the outlet or fixture, and the receiver is used to scan the circuit breakers in the panel. When the receiver detects the signal from the transmitter, it indicates the correct breaker. Another method is the process of elimination. Turn off all circuit breakers in the panel. Then turn on one breaker at a time and check which outlets or fixtures are energized. Label the breaker accordingly. Repeat this process for each breaker until all circuits are identified. You can use a multimeter to verify the voltage at outlets and fixtures. A multimeter can also be used to check for continuity, which can help you trace circuits and identify wiring issues. Another method is visual inspection. Examine the wiring in the panel and the outlets and fixtures. Look for any markings or labels that might indicate the circuit number or the area it serves. Sometimes the wire colors can provide clues, but this is not always reliable. You might need to create a circuit directory. Once you have identified all the circuits, create a detailed circuit directory and attach it to the inside of the panel door. This directory should list each breaker and the corresponding outlets, fixtures, and appliances it controls. Now let's look at electrical code compliance. Electrical codes are put in place to ensure the safety of electrical installations and protect people and property from electrical hazards. When working on an older electrical system, it is essential to identify and correct any code violations to bring the system up to current standards. Grounding and bonding are critical for electrical safety. Verify that all circuits are properly grounded and bonded according to the current electrical code. This includes grounding conductors and cables, grounding electrodes, and bonding of metal enclosures and equipment. Look at conductor sizing. The size of electrical conductors must be appropriate for the amount of current they are intended to carry. Check the conductor sizes in the existing wiring and compare them to the ampacity ratings in the electrical code. Replace any undersized conductors with the correct size. Overcurrent protection is a fundamental safety requirement. Ensure that all circuits are protected by circuit breakers or fuses of the correct size. The overcurrent protection device should be sized to protect the conductors and equipment in the circuit. Examine wiring methods. The wiring methods used in the electrical system must comply with the electrical code. Check for any improper wiring methods, such as exposed wiring, damaged insulation, or improper connections. Correct any deficiencies to ensure safe and reliable electrical connections. Inspect the junction boxes. Junction boxes are enclosures used to protect electrical connections. Verify that all junction boxes are properly installed, accessible, and have the correct covers. Make sure that all electrical connections inside junction boxes are secure and properly insulated. GFCI protection is required in areas where there is a high risk of electric shock, such as bathrooms, kitchens, and outdoor locations. Install GFCI outlets or circuit breakers to protect these areas. SI protection is designed to protect against arc faults, which can cause fires. SI protection is required in many areas of the home, such as bedrooms and living rooms. Install SI circuit breakers to protect these areas. In conclusion, when estimating electrical finish work on an older rough-in, it's essential to consider material costs, labor costs, cable tracing, code corrections, and the possibility of needing a new electrical panel. Providing a detailed breakdown of your estimate will make sure that the general contractor knows the value and work that you are putting into the project. Understanding the electrical panel, identifying circuits, and ensuring electrical code compliance will contribute to an estimate that is both precise and thorough.